All right, this is lesson 2.5, linear inequalities in two variables, part 2. So these are a lot of contextual problems where you're picking out some keywords out of each of these little paragraphs. Since we're talking about inequalities, what I want you to focus on are phrases like this, where you see something that says at most. That's an important phrase for an inequality. Or down here in number 2, we see at least. Those are key words that help you focus on what type of symbol you need to use for each of the problems. So this first one says a baker is making chocolate cakes and vanilla cupcakes. He can make at most 12 cakes at one time. Write an inequality to find the number of chocolate cakes, X, and vanilla cakes, cupcakes, Y, he could bake. All right, so since these are in two variables, we're going to be using both of those, X and Y. So we could say that the number of chocolate cakes, X, plus the number of vanilla cupcakes, Y, has to be at most 12. So we could have 12, so we're going to say or equal to here. But since 12 is the most that we could have, our number of chocolate cakes and vanilla cupcakes has to stay less than 12 or equal to that. In number 2, teenagers should consume at least 1,200 milligrams of calcium per day. Suppose you get calcium from 2 different sources. Those are our 2 variables, skim milk and cheddar cheese. 1 cup of skim milk supplies 296 milligrams. And also, I think it would be a good idea to have a highlighter when you do these contextual problems, help you pick out those key phrases and key numbers. And 1 slice of cheddar cheese supplies 338 milligrams of calcium. Write an inequality that represents the amount of skim milk, X. So skim milk is our X here. And cheddar cheese, Y, you need to consume to meet your daily requirement of calcium. All right, so every amount of X, every amount of skim milk, we're going to get 296 milligrams per cup of skim milk. We're going to get 338 milligrams per cup of cheddar cheese. If we add those together, we need at least 1,200 milligrams in our day. So we could get 1,200, so it's going to be or equal to, but we would also like to have possibly more than that. So it's going to be greater than or equal to. Maria is planning a celebration. At the party, she will give away $5 gift cards and $4 candy packs as prizes. Maria has $100 to spend. Write and graph an inequality to find the number of gift cards, X, and candy packs, Y, Maria could purchase. All right, so we're going to write an inequality, and then we're also going to come up with a graph for that inequality over there on the grid. So if we spend $5 per gift card, $5 for every X, and $4 for every candy pack, $4 for every Y, when we add those together, we need to stay less than or equal to $100 that she can spend. So that's a good inequality to write for this. Now what we want to focus on is coming up with a graph for that. So here we actually are going to want to solve this for y to come up with our graph. So I'm going to take away the 5x. From both sides of the inequality, and then I'm going to divide by 4 on both sides of the inequality. All right, then maybe I'll flip it around and write it in slope-intercept form instead of intercept-slope form. So when I look at this, I see that my intercept is going to be up here at 25. That's my y-intercept. That happens when x is 0. And then I'm going to go down 5 for every time I go over 4. I'm going to have a point right here. Okay, and maybe I'll even skip ahead and just go down 25 and over 20, since that's going to follow the same ratio. Here's my line. Now, I'm going to make this a solid line because she could spend $100. And then I'm going to shade underneath here. These are all the amounts that she could purchase in terms of gift cards and candy packs to stay under $100. So if we pick a test point here, she could purchase, say, let's say 5 gift cards, and she could purchase 15 candy packs, and she would be well within her range of spending $100. Now, in part B, it says, if Maria wants to buy 10 candy packs, how many gift cards can she purchase based on our inequality here? So if we buy 10 candy packs, instead of a y, I'm now going to have a 10. And we want to make sure that that's underneath $100 still, or equal to 100. So 5x is going to equal, or stay less than or equal to 60. And x is going to stay less than or equal to 12. Okay, so if we look at this, 10 candy packs and 12 gift cards, that's going to be right here on our line. In part C, I'm almost wondering if this is a typo, because if we buy 22 gift cards, then we're already under, or I'm sorry, over our $100, because each one is $5, that would be $110. So let's say that we purchase 22 candy packs, and let's see how many gift cards we can purchase. If we purchase 22 gift cards and we're over here, we're outside of this range, okay? So if we purchase 22 candy packs, then we could say that 5x plus 4 times 22 has to stay less than or equal to 100. So 5x has to stay less than or equal to 12. So x has to stay less than or equal to, well, let's see, that would be 2 2/5. So technically, we can't really buy 2/5 of a candy pack. Technically, x should stay less than or equal to 2. Okay, because if we purchase 22 candy packs, that's going to be way up here. All right, so we don't have a lot of room to get over to the line to purchase any more gift cards. All right, number 4, it says the royalties for the high school play are $240. Tickets cost $6 per student, X, and $8 per adult, Y. Write and graph an inequality that describes the number of student and adult tickets that need to be sold so that the drama class can pay for the royalties. So they're trying to get at least $240 to pay off those royalties. So they want something, they would love something more than that or equal to 240 when you add up the amounts that they get from those two types of tickets. Okay, so again, when we graph this, we can say that we're going to solve it for y. We can say that 8y is greater than or equal to 240 minus 6x. So then when we divide by 8, we can say that y has to be greater than or equal to 30 minus 6/8, so that's going to be 3/4 x. Right? And then typically we're going to put that in slope-intercept form. So I would say negative 3/4 x plus 30. My y-intercept is up here at 30. If I go down 30, I can go over 40. And that's the same as going down 3/4. So this is going to be my line. Okay. Now I'm going to shade up here because we want to make more than that. We want to at least make 240, but technically we want to make more than that. Okay, so if they sell 10 student tickets and 20 adult tickets, will they make enough to pay for the royalties? Let's take a look. So in this situation, this is kind of like my s-axis for students. This is the adult axis, okay? So 10 student tickets, 6 times 10, plus 20 adult tickets, 8 times 20. Trying to see, is that more than or equal to 240? So this is 60 plus 160. If I put those together, I have 220, which is not more than or equal to 240. So let's see, if we plot this point, 10 comma 20, that's right here. Okay, it's not on our line and it's not within our highlighted range, so we know that that's not going to work.